Let's take one more example under this kind of problem. This is 1b. Let's call it 1b. This is like a polynomial kind of problem. And so, looking at this polynomial kind of integration problem, what do you think we should do? How should we approach this problem? I believe you've heard about partial fractions before. Yes. Um, partial fractions. We'll also learn that obviously in this class, partial fractions. But when you're given a problem, ordinary differential equation problem, don't just say, oh, this problem I will use partial fractions immediately. Try to do some simplifications. Since this is polynomial, it means that is it possible to break this big polynomial expression to a smaller chunk? So if yes, let's say for instance, if yes, then that means I should try to divide x squared plus 1. Like I should try to see if there is a way I can break it down so that it will be easy for you to solve. Don't just look at this like this, because if you look at it like this, you might get overwhelmed. But don't look at it like this. First thing is, can I divide this? Can I simplify this more? And the question is yes, you can simplify it more. So let's try to simplify this problem. You remember your division. Let's say we'll divide. And you have x squared plus 1 here, square minus x plus 1. Right. So this is 1, right? And this is x squared plus 1. So you subtract this from this, negative x, negative 1, right? So, and this is what? Yeah, this is 0, right? Sorry. This is, sorry, this is, yeah, this negative x. Yeah. Do you see that? So this means that I can rewrite this guy as 1 minus x over x squared plus 1 dx. Yes, that's right. Do you see? So now, just by polynomial division, we're able to break the large expression, polynomial expression, to a smaller chunk, which now looks easy. So, I can rewrite this as the integral of 1 dx negative the integral of x over x squared plus 1 dx. Is that correct? So that means that this becomes x negative. So what's, if you integrate this, what do you have? What is it? I'm hearing the sound of the answer from you already, but there are still some things you need to put maybe behind. What do you think? Just think about it. What is it? Exactly. Yes. So that means that I can rewrite this problem as 1 over 2 dot 2x over x squared plus 1 dx. Do you know that? Now, You might want to know, how do you know that we ought to move this one to this one? Now, the simple idea is this. You know very well that if you integrate 1 over x dx, what do you have? That's natural log x plus c. Is that correct? Yes. The question is, how do you know this? What you have to look at first is the denominator. The question is, the idea is this. If you can differentiate the denominator and it gives you the numerator, then your final solution should be the natural log of your denominator. Do we understand? You know, this is your numerator. This is your denominator. Now, if you can differentiate the denominator and it gives you the numerator, it means that you have the natural log of the denominator. It will be the natural log of the denominator plus whatsoever if it is an indefinite integral. So if you look at this problem, you discover that in the denominator here, you are having x squared plus 1. Now, apply the idea. If I differentiate with respect to x, what do I have? 2x. So this means that, but if you look at the numerator, you only have x. So it means that I need a coefficient, a constant coefficient. And it is easy to manipulate a constant coefficient. Right? It is easy to manipulate out a constant coefficient by just putting this 1/2, multiply it by this. It's still the same thing as 2 cancelling out 2, giving you x over x squared plus 1. It's still the same thing. But because you're smart, you know already that, oh, let me just manipulate the coefficient to give me what I need, because you need it in the structure of something like this. So just because of that, your final solution will be x negative 1 over 2 natural log of x squared plus 1 plus c.